In the spring of 2021, a trail camera positioned at a water source in the Kofa National Wildlife Refuge in western Arizona captured an image that the biologist reviewing the footage had to look at twice before she trusted what she was seeing. Standing at the edge of the water, in a landscape of saguaro cactus and creosote flat and ancient volcanic rock that bakes in summer to temperatures exceeding 115 degrees Fahrenheit, was a black bear. Not a large one. A young male, probably 2 or 3 years old, thin in a way that suggested the journey behind him had been long and not easy. The refuge sits in the lower third of Arizona, well below the Mogollon Rim, well below the Sky Island mountain ranges that have historically served as the southern Arizona strongholds for Ursus americanus. The bear had no business being there by any conventional understanding of where black bears go and why they go there. The Kofa is Sonoran Desert. It is one of the driest and most thermally extreme landscapes in North America. It is bighorn sheep country and Gambel's quail country and Gila woodpecker country. It is not, by the ecological understanding that has governed wildlife management in the Southwest for the past century, bear country. And yet the camera did not lie, and the bear stood at the water for several minutes, drank deeply, and disappeared into the rocks. If you find the things that happen at the edge of what we think we know compelling, if you find the places where maps and reality stop matching each other worth paying close attention to, consider subscribing. This is the kind of story that deserves a wide audience, and your subscription makes it possible to keep telling it. The Kofa sighting was not an isolated anomaly, though it would have been easy to treat it as one. Isolated anomalies are comfortable. An isolated anomaly is a statistical curiosity, a data point that sits outside the trend line without demanding that the trend line be reconsidered. Wildlife managers in the desert Southwest have been treating individual black bear sightings in unexpected places as isolated anomalies for roughly 20 years. The problem with that framing is that the anomalies have been accumulating. They have been accumulating in Nevada. They have been accumulating in Utah's canyon country. They have been accumulating in the low desert of New Mexico. They have been accumulating, most emphatically and most documentably, in southern and western Arizona, in landscapes that the species has not occupied in any recorded history and that the prevailing ecological models suggested it could not occupy, because the conditions were wrong. The temperature was too extreme, the water was too scarce, the food resources were too sparse and too seasonal. The distances from established bear range were too great for dispersal to bridge. The conventional understanding of black bear ecology was built on a century of observation in places where black bears lived, and the conclusion of that understanding was a distributional map with clear edges. The desert states were outside the edges. They were in the white space on the map where bears were not. The map is wrong. Or more precisely, the map was correct for the conditions it was built under. And the conditions have changed in ways that are moving the edges, and the edges are now somewhere that the map does not show, and the bears are in the white space. That is the situation. The question that follows from it is what it means, not just ecologically, not just for wildlife management, not just for the bears themselves, but for every person who recreates in the desert Southwest, under the assumption that the large carnivore they do not need to think about in a desert landscape is in fact not there. That assumption is increasingly incorrect. The rate at which it is becoming incorrect is accelerating. The reasons why are instructive, because they are not simple, and they are not going to resolve themselves back toward the old map. The old map is gone. To understand why black bears are appearing in desert landscapes that have no history of supporting them, it is necessary to understand something about black bear biology that distinguishes the species from virtually every other large carnivore in North America. Black bears are not specialists. They are the opposite of specialists. Ursus americanus is the most broadly distributed bear species on the continent, and one of the most ecologically flexible large mammals in the Northern Hemisphere. The species occupies everything from the temperate rainforests of the Pacific Northwest to the boreal forests of interior Alaska to the subtropical swamps of Florida. It occupies the Appalachian Highlands and the Louisiana bottomlands, and the oak scrub of central Texas, and the mixed conifer forests of the Colorado Rockies. This distributional breadth is not an accident of geography or history. It is a direct expression of the animal's biological organization. Black bears are omnivores of extraordinary range. Their diet in any given season is determined by what is available in their current location and their current season, not by a narrow physiological or behavioral specialization that requires specific prey or specific vegetation structure. They eat berries, acorns, grass, insects, carrion, fish, small mammals, bird eggs, honey, roots, and essentially anything else that provides caloric return on the investment of acquiring it. Their digestive system is flexible. Their foraging behavior is cognitively driven rather than instinct-locked. They learn what is available in a landscape by moving through it and experimenting. They remember where food was and return to it. They communicate nothing about food location to other bears, maintaining the solitary foraging strategy that keeps resource competition within manageable bounds. This combination of dietary flexibility, spatial memory, learning capacity, and solitary strategy makes black bears among the most adaptable large mammals on the planet in response to changing environmental conditions, where a more specialized predator requires the specific ecological community it evolved within. The black bear requires only that a landscape offer some minimum threshold of food and water across its annual cycle. The question of what that minimum threshold is has historically been answered by the distributional limits of the species, which excluded the hottest and driest of the desert landscapes in the American Southwest. The implicit answer was that the desert Southwest fell below the threshold. The bears were telling us, in their absence, that the conditions were not adequate. Now, some of them are telling us something different, and the question is whether the bears have changed or the desert has changed. The answer is both, and the interaction between the two changes is what is producing the range expansion that wildlife managers are only beginning to formally acknowledge. The climatic dimension of this story requires careful handling because it is both genuinely important and frequently discussed in ways that obscure more than they reveal. The American Southwest has been warming and drying, in a statistical aggregate sense, over the past several decades. The scientific record on this is robust and not seriously contested in the literature. What is more complex and more relevant to the specific question of black bear range expansion is how that warming and drying has interacted with vegetation community dynamics in the mountainous and semi-arid terrain at the edge of bear range. The intuitive assumption might be that warming and drying would push bears further from the desert, making the low-elevation, hot landscapes even less hospitable than they already were. The actual dynamics are more complicated and, in some respects, counterintuitive. The Sky Island mountain ranges of southeastern Arizona, which have served as the primary source population for the bears now appearing in the surrounding desert lowlands, have been experiencing a significant ecological transformation over the past 2 to 3 decades. The Pinaleño Mountains, the Santa Catalinas, the Chiricahuas, the Galiuro Range, the Santa Ritas. These ranges are fire-adapted systems that have historically cycled through periods of high-density vegetation and periodic fire. Fire suppression through most of the 20th century allowed fuels to accumulate beyond historical levels. And when ignition occurred, often from lightning in the summer monsoon season, the fires that resulted were larger and more severe than the landscape had experienced in its ecological history. The large fires of the 2000s and 2010s in the Sky Islands, events like the Wallow Fire of 2011, which burned nearly 500,000 acres of the White Mountains and the adjacent ranges, transformed the vegetation structure of the forests in ways that have complex cascading effects on the animals that use them. For black bears, these fire effects have not been uniformly negative. Bears are among the first large mammals to return to burned landscapes because fire creates conditions that favor the plant communities they depend on most heavily during the summer and early fall caloric loading period. Burned forest generates prolific growth of berry-producing shrubs, particularly manzanita, elderberry, and various ribes species, in the years following fire. The bear population in the Sky Islands has not been devastated by the large fires. In some areas, the post-fire vegetation response has temporarily increased carrying capacity for bears at middle elevations. But the spatial distribution of these resources has been restructured. The patchwork of burned and unburned terrain, the altered connectivity between foraging areas, and the increased fragmentation of mature forest have created conditions that push individual bears, particularly young males, dispersing from their natal ranges, to move further and explore more before finding territory or resources that allow them to settle. Young male black bears are the primary dispersers in the species. They leave their mother's home ranges as subadults and move, often long distances, in search of areas where they can establish territories without running into the dominant adult males who would drive them out. In a landscape where the vegetation structure has been altered by large fires, where the traditional dispersal corridors have been modified, and where the competitive pressure from established adults remains high, young males may move further and in less predictable directions than they have historically. Some of them are moving into the desert. The question is whether they are surviving when they get there, and if they are surviving, whether they are establishing themselves permanently or representing terminal dispersal events, animals that make it into the desert but cannot persist there long enough to reproduce. The answer, based on the accumulating evidence from camera traps, GPS collaring programs, and the increasing frequency of confirmed sightings over the past decade, appears to be that some of them are surviving, and that the threshold conditions in the desert are not, in all locations and all seasons, as prohibitive as historical range maps suggested. The water question is the first and most fundamental issue for a bear in a desert landscape, because bears require substantial water intake, particularly in the hot season, when they are moving and foraging before the monsoon rains transform the desert. The conventional assumption was that the desert's water scarcity made it impassable for bears during the critical summer months, when temperatures in the lower elevations regularly exceed 110 degrees. This assumption was reasonable when it was formed, and it remains roughly correct for the most arid and waterless of the desert landscapes. But it does not account adequately for the distribution of permanent and semi-permanent water in the Sonoran and Chihuahuan desert regions of Arizona and New Mexico. The two states collectively have a water infrastructure in the desert that is more extensive than most people who have not thought carefully about it would assume. Stock tanks, developed by ranching operations across the desert and its foothills over more than a century, are distributed across the landscape in numbers that represent a significant modification of the natural water regime. Wildlife agencies in both states have added to this infrastructure through their own water development programs. Specifically, the guzzler systems installed for desert bighorn sheep and other desert wildlife. Riparian corridors, however degraded and intermittent, persist along the courses of rivers like the San Pedro, the Gila, the Verde, and their tributaries. Agricultural irrigation in the larger desert valleys has created persistent vegetation and moisture conditions that did not exist in the pre-settlement landscape. A black bear moving through the Sonoran Desert of southern Arizona is moving through a landscape with more water than its ecological absence historically implied. The water is not everywhere, It is not sufficient to support a bear population at high density, but it is sufficient, apparently, to support the movement of individual animals through the landscape, and in some areas, to support extended residence. The GPS data from bears that have been collared in the Sky Islands and tracked into the desert lowlands shows animals navigating between water sources with a spatial logic that suggests learning rather than random movement. They are not wandering blindly into the desert and dying of thirst. They are moving between known or discovered water points with a directionality and efficiency that reflects the cognitive mapping ability the species is documented to possess. Bears remember water. They remember food. They learn landscapes. A bear that crosses the desert successfully carries a spatial memory of that crossing that will inform its future movements, and potentially the future movements of cubs it may rear if it survives to reproduce. The food dimension in the desert is more limiting than the water dimension, but it is also more complex than a simple reading of desert ecology would suggest. The Sonoran Desert is not foodless. It is not the featureless sand desert of popular imagination. It is a richly structured ecosystem with substantial plant diversity, significant insect biomass during the monsoon season, an extensive small mammal community, a diverse bird community, and the fruits and pads of cacti that represent a caloric resource that no bear has evolved to exploit, but that a sufficiently hungry and flexible bear can, and apparently does, utilize. The saguaro cactus fruit, which ripens in late June and July, and is one of the most nutritionally dense food items in the Sonoran Desert ecosystem, has been documented in the stomach contents of bears killed or captured in the desert lowlands. The same bear that spent the previous fall eating acorns in the Pinaleño Mountains at 6,000 feet is eating saguaro fruit in the desert flats at 2,000 feet in July. This is not behavior that any textbook on black bear ecology anticipated. It is behavior that the bears are inventing in real time as they encounter new landscapes and test new food sources with the exploratory intelligence the species is capable of. The prickly pear cactus, which is distributed far more broadly than the saguaro and extends well into the higher desert elevations, is a documented food source for bears across the borderland region. Prickly pear produces fruit that is sweet and caloric, and, once a bear has learned to handle the spines, accessible in quantity during late summer. The mesquite pods that carpet the desert floor in years of good pod production represent another caloric resource that bears in the desert lowlands have been documented exploiting. Agave hearts, which contain concentrated carbohydrates and are traditionally harvested by humans for exactly that caloric density, are accessible to a bear strong enough to dig and tear the plant apart. The desert Southwest, examined through the lens of what a flexible, intelligent, powerful omnivore can find and utilize, is not as inhospitable as the absence of bears in the historical record suggested. The absence may have been more about connectivity than about carrying capacity. The desert was a barrier to dispersal from the mountain source populations, not necessarily a habitat that could not support individual bears once they arrived. The barriers appear, for some animals in some corridors, to be becoming more permeable. Climate change is contributing to this permeability in ways that are not linear and not always in the direction one might assume. The warming of winter temperatures in the desert Southwest has reduced the severity and duration of cold periods that historically posed a lethal challenge to any bear attempting to overwinter at low elevation. Black bears do not technically hibernate in the strict physiological sense. They enter a state of torpor from which they can be roused, but they do dramatically reduce their metabolic rate and their movement during cold periods, and rely on fat reserves accumulated during the fall. In the desert lowlands, where historical winter temperatures could drop to levels that would challenge a bear not adapted to low-elevation desert conditions, the warming trend has reduced the physiological stress of the cold season for bears attempting to establish year-round residence. The warming has simultaneously extended the growing season for some of the plant species that bears exploit, particularly the cactus species whose fruiting windows are temperature-sensitive. The net climatic effect on bear habitat suitability in the desert lowlands is not simply negative. In some ways, the climate is moving in directions that reduce the cost of bear presence in the desert, even as it is simultaneously reducing the ecological quality of the higher elevation source habitats in ways that increase the dispersal pressure pushing bears out of them. The human landscape dimension of this expansion is something that wildlife managers have been slow to address publicly, but that the data increasingly demands attention to. The pattern of black bear appearances in desert communities in Arizona and New Mexico over the past decade does not map cleanly onto the pattern of natural dispersal through wild terrain. It maps, in significant part, onto the human development footprint. Bears appearing in Tucson's eastern neighborhoods and in the developments along the Santa Catalina mountain foothills are not purely wild animals moving through pristine desert. They are animals moving through a landscape that has been profoundly modified by human development in ways that, for a bear, represent both challenge and opportunity. The challenge is obvious. Traffic is lethal. Human density creates encounter risk. The legal and management response to bears in residential areas is swift and often fatal for the animal. The opportunity is less obvious, but equally real. The urban and suburban interface in the Sonoran Desert is, from a black bear's perspective, an extraordinarily productive foraging landscape. Residential areas adjacent to Desert Preserve generate a food abundance that the surrounding natural desert cannot match. Garbage and trash represent concentrated, easily accessible caloric resources that bears in the western United States have been exploiting in developed areas for as long as bears and developed areas have overlapped. Fruit trees, which are planted extensively in the low desert of Arizona and New Mexico because the climate supports year-round growing, represent a caloric windfall for a bear in a landscape where wild fruits are seasonal and dispersed. Bird feeders, which in the desert southwest are maintained in large numbers by a population deeply committed to supporting desert bird diversity, represent easy sugar and fat that a bear can consume in quantity with minimal effort. Pet food left outdoors, which in the desert communities at the foot of the Sky Island ranges is common, represents the same opportunity. The urban-adjacent desert landscape, populated by water-efficient landscaping, irrigated citrus orchards, irrigated vegetable gardens, bird feeders, trash receptacles, and pet food bowls, is producing a food reward structure that is actively drawing bears out of the wild terrain at the forest edge and into the developed landscape. This is not a new phenomenon in bear-human dynamics. It has played out across the American West, wherever black bear populations have come into contact with residential development at the wildland-urban interface. What is new in the desert Southwest context is the geography. Bears at the wildland-urban interface in Colorado, New Mexico's higher elevations, and California are animals that have been present in the surrounding landscape for a long time. The conflicts that arise are the expression of a pre-existing population pushing into developed areas as the areas expand. In the low desert of Arizona, the dynamic is different. The bears arriving in the developed areas are not animals from a pre-existing local population. They are animals completing range expansion into territory where no local population previously existed. They are discovering, upon arrival, that the developed landscape offers resources that make extended residence viable in a way that the surrounding wild desert may not. Some of them are staying, not in large numbers, not in ways that wildlife managers have formally characterized as population establishment, but the accumulation of individual bears making extended residence in the low-elevation desert, some of them in areas with significant human development, is producing a situation that the existing management frameworks were not designed to address. The management challenge is compounded by a regulatory reality that is genuinely awkward. Black bears in Arizona are managed as a game species under the jurisdiction of the Arizona Game and Fish Department. The management framework was built around a bear population that occupies the forests and mountains of central and eastern Arizona, the known range, and that interacts with hunters, hikers, and rural communities in ways that the department has decades of experience managing. The regulatory infrastructure for dealing with bears in the Sonoran Desert lowlands, which is formally outside the documented range, is essentially the same infrastructure applied to a situation it was not designed for. Problem bear protocols exist and are functional. Wildlife managers can remove, relocate, or euthanize individual bears that demonstrate habituation or conflict behavior. What the existing framework does not accommodate well is the broader question of what the department's management posture should be toward a range expansion that is happening at the edge of its documented territory, driven by forces that the department does not control, into a landscape whose human communities were not designed with bears in mind and whose residents have no cultural or experiential baseline for coexisting with a large omnivore. The same situation, with local variations, is playing out in Nevada and Utah, where black bears have been appearing with increasing frequency in landscapes that the existing range maps do not include. Nevada is a state where the black bear's documented range has historically been limited to the Great Basin ranges in the far northern part of the state, particularly the Ruby Mountains, and the adjacent ranges near the Idaho border. The bear population in that region is genuine and has been resident for a long time. It is not that population, however, that is generating the sightings that have been documented in recent years in the ranges of southern Nevada, including mountain systems within a relatively short drive of Las Vegas. Southern Nevada was, until very recently, firmly in the white space on the bear distribution map. It is now receiving enough individual bear sightings and enough camera trap confirmations to require explanation that the white space no longer provides. The southern Nevada sightings are almost certainly connected to movement from the Spring Mountains, a significant range that rises above 8,000 feet immediately west of the Las Vegas metropolitan area, and that represents the southernmost significant mountain range in Nevada, with the elevation, vegetation, and water resources to potentially support bears. The Spring Mountains have not historically had a resident bear population, but they have the ecological structure that could support one, and their proximity to the ranges of southern Utah and northern Arizona, where bear populations are more established, makes them a plausible destination for dispersing individuals. GPS tracking data from bears in southern Utah and northern Arizona has documented long-distance movements of young males that cover ground at rates and over distances that would bring them to the Spring Mountains within the course of a single dispersal event. If those animals find the Spring Mountains hospitable, and there is reason to think they might, the mountains represent a stepping stone toward the lower elevation terrain below them, including terrain that edges toward the Las Vegas Valley. The Las Vegas metropolitan area has not had formal confirmed bear encounters in residential areas as of the most recent reporting periods. The trajectory of the situation, based on what is happening in the surrounding mountains and based on the pattern of developments in comparable situations in other states, suggests that will change. The pattern in other states is consistent enough to be instructive. Mountain ranges receive dispersing bears. Individual animals extend their movements into the developed areas at the base of the mountains. Food rewards in developed areas slow or halt further dispersal. Bears that find food in residential areas return to those areas. The community discovers it has a bear problem before it has had any time to develop the cultural, regulatory, or practical infrastructure for managing one. The management response is reactive and expensive and often produces outcomes, primarily lethal removal of individual animals, that are unsatisfying to the portion of the community that wants bears managed humanely, and inadequate to the portion of the community that wants bears gone. Utah presents a somewhat different version of the same general story. The state has a genuine and well-documented black bear population in its mountain ranges, including the Wasatch Range, the Uintas, the Manti La Sal, and several ranges in the southern part of the state. The southern Utah population, concentrated in the Cedar and Beaver Mountains and the ranges of the Colorado Plateau, is the one most relevant to the expansion question, because it is the population closest to the canyon country and high desert terrain of the Colorado Plateau that lies to its south and east. Bears in southern Utah have been documented in the canyon country terrain of the Colorado Plateau, specifically in landscapes dominated by slick rock, cryptobiotic soil crust, pinyon juniper woodland, and riparian corridors along the rivers that have carved the canyon systems, at frequencies that have been increasing over the past decade. The canyon country of southern Utah is not empty of food or water from a bear's perspective. The pinyon juniper woodland that covers much of the plateau country at mid-elevations produces mast crops of both pinyon pine nuts and juniper berries that can be locally very abundant in good years. The riparian corridors along the Colorado, Green, Escalante, and Paria rivers and their tributaries produce vegetation communities that are rich relative to the surrounding desert. The deer population of the Colorado Plateau, which supports a significant mule deer herd that moves through the canyon country, represents prey opportunity that a sufficiently opportunistic bear will exploit. The bears appearing in the canyon country of southern Utah are encountering a human population that uses the landscape intensively, but in a specific way. Southern Utah is one of the most heavily visited public land landscapes in the United States. The national parks of the Colorado Plateau, Zion, Bryce Canyon, Capitol Reef, Canyonlands, and Arches collectively receive millions of visitors annually. The infrastructure that serves those visitors, the campgrounds, picnic areas, overnight backcountry sites, and the waste management systems that serve all of them, represents exactly the kind of food concentration that draws bears that have discovered its presence. Campground bears are one of the most well-documented management challenges in American wildlife management. The national parks of the American West have spent decades and enormous resources developing food storage infrastructure, bear-proof containers, airtight food storage lockers, and the accompanying regulatory and educational frameworks to minimize the food reward structure in campgrounds and backcountry campsites. That infrastructure exists in the parks, where bears have been historically present. It does not exist, or exists in minimal form, in the campgrounds and recreation areas of the canyon country parks and monuments, where bears have historically not been present, and where park managers are only now beginning to recognize that the historical absence may be ending. The food conditioning problem is the most acute and most irreversible management challenge that comes with black bear range expansion into areas that were not previously bear habitat. Food conditioning occurs when an individual bear discovers human-associated food sources, garbage, bird feeders, campground food, agricultural produce, and incorporates them into its regular foraging behavior. A food-conditioned bear is not simply a bear that has eaten human food. It is an animal whose spatial memory has been updated to include human-associated areas as reliable foraging destinations, whose behavioral inhibitions about approaching human presence have been reduced by the reward experience of finding food near humans, and whose home range has reorganized itself around the distribution of human-associated food sources rather than the distribution of natural food. Food conditioning is essentially irreversible in individual animals. A food-conditioned bear cannot be retrained to avoid human food. Relocation is only temporarily effective, as documented repeatedly in the scientific literature and in the operational experience of bear managers across the country. Food-conditioned bears that are relocated typically return to human-associated areas, sometimes covering extraordinary distances to do so, or find new human-associated food sources in their relocation area and establish the same pattern. The management response to a confirmed food-conditioned bear is almost always lethal removal, because no non-lethal alternative has been demonstrated to work at a level that protects public safety and resolves the conflict. The prevention of food conditioning is therefore not just a wildlife welfare concern. It is the fundamental management priority in any situation where bears are expanding into new areas with significant human presence. Prevention requires that human-associated food sources be made inaccessible before bears discover them, not after the first food-conditioned individual has been removed. It requires that the communities, the recreation managers, the campground operators, the residents of the foothills, and the park visitors understand the situation before it becomes a problem, not as a response to incidents that have already occurred and animals that have already been conditioned. The track record of bear management in the American West, across decades and across states, is that this proactive approach is extremely difficult to achieve in practice. Regulations requiring bear-proof storage are typically enacted after incidents have demonstrated the need. Education programs reach the visitors who are already interested, rather than the ones who are going to leave their camp food out. Communities that have never had bears do not have the cultural knowledge or the urgency to implement the infrastructure changes that prevention requires. By the time the awareness exists, the first wave of food-conditioned animals has already gone through the system, and the management response is reactive and lethal and expensive, and generates community conflict that poisons the political environment for the long-term coexistence management that would actually work. The human safety dimension of this expansion, which is not the largest part of the story, but which is the part most likely to shape public and political response, requires honest treatment. Black bears kill far fewer people than mountain lions. In any given year in North America, the number of people killed by black bears is in the low single digits. Over the entire recorded history of North America, black bear fatalities are more numerous than mountain lion fatalities, but not by the kind of margin that changes the risk calculus for an individual recreating in bear habitat. Black bears are not, in aggregate, dangerous to humans in the sense that their presence represents a meaningful threat to human life and safety across the population. The risk is real but small, and the qualifications on it are important. Most black bear attacks are defensive in nature, occurring when bears are startled at close range or when a female with cubs is approached. Predatory attacks, in which a bear targets a human as prey, are the minority of attacks, but represent the majority of fatalities. The profile of the predatory attacker in the black bear literature is a young or middle-aged male, often in poor nutritional condition, often in a remote area where the bear has little history of human exposure, sometimes in an area where the bear has had some prior exposure to human food. That last profile, the nutritionally stressed male with some food conditioning history, is worth paying attention to in the context of the desert range expansion. The bears appearing in desert communities in Arizona are not wild conditioned mountain animals with a deeply established wariness of humans. They are dispersing young animals, often in nutritional stress, from the journey and from the difficulty of foraging in an unfamiliar landscape, arriving in an environment where human food sources may represent the difference between surviving and not surviving. A bear in that condition that discovers a campground, a residential garbage area, or a ranching operation with accessible food is not going to apply the behavioral caution of a well-fed animal with an established home range and a history of negative encounters with humans. It is going to eat, and eating in the presence of humans without negative consequence is the beginning of the conditioning process. The bears most likely to arrive in the desert communities of southern Arizona and Nevada are, by the logic of the dispersal process and the nutritional demands of long-distance movement through harsh terrain, precisely the animals most vulnerable to food conditioning. The management challenge is therefore not simply that bears are appearing in new places. It is that the bears appearing in new places are appearing in a behavioral state that makes the most problematic management outcomes more likely. The institutional response to this situation has been, predictably and understandably, cautious. Wildlife agencies in the desert states occupy a difficult position. They are responsible for managing a range expansion they did not anticipate and do not control, with existing staff and existing regulatory frameworks that were not designed for it. In communities whose public and political expectations about wildlife were formed without any reference to bears as local residents, they are managing toward a future whose shape they cannot clearly define. They do not know whether the individual bears appearing in the desert represent the vanguard of a genuine population establishment or a series of terminal dispersal events. They do not know whether the conditions that are pushing bears into the desert are temporary fluctuations or permanent directional changes. They do not know whether the desert communities they are serving can or will implement the preventive measures that would reduce the probability of conflict. In that context of genuine uncertainty, the institutional tendency is toward caution in communication. Say less rather than more. Avoid alarming communities unnecessarily. Manage individual incidents as they arise. Do not make formal announcements about range changes that would generate political and media attention before the situation is clearly enough defined to defend. That caution is understandable. It is also producing an information environment in which the communities most likely to encounter bears in the coming years are the least prepared for it. The communities of southern Arizona's high desert foothills, the small cities and ranching communities that sit between the Sky Island mountain ranges and the desert floor, the recreation visitors to southern Utah's canyon country, the trail runners and mountain bikers and backcountry campers who are increasingly using landscapes in the desert southwest that were never posted with bear country warnings because bears were not there. All of them are operating on a set of assumptions about the wildlife hazard profile of their landscape that the current situation does not support. They are leaving food out in ways they would not if they knew bears were in the area. They are hiking alone in draws and canyon bottoms in ways they would modify if they understood the changing situation. They are failing to install the bear-proof infrastructure that would prevent food conditioning before it starts. Not because they are careless or ignorant in a culpable sense, but because no one has told them in clear and direct terms that the landscape they are using has changed in a way that requires them to change their behavior. The cultural dimension of bear encounters in communities that have no history of bears is something that deserves its own careful examination because it generates a specific kind of conflict that is both predictable and damaging to the long-term prospects for coexistence. In communities that have long histories of living alongside bears, a bear encounter generates a response shaped by experience and cultural knowledge. People know what to do because they have been taught what to do, formally through wildlife agency education programs and informally through community knowledge passed between neighbors and family members. They know to secure their garbage. They know to take down bird feeders in season. They know to make noise on the trail. They know to keep dogs on leash. They know that a bear in the yard is usually manageable and that calling the wildlife agency is the right step when it is not. This cultural knowledge is not glamorous or exciting. It is the accumulated, practical wisdom of communities that have worked out, over generations and incidents, how to live alongside a large omnivore without constant crisis. The desert communities of Arizona, Nevada, and Utah do not have this cultural knowledge. They are about to need it. The timeline for when they will need it in earnest is not certain, but the direction of the trend is not in doubt. The accumulation of bear sightings, camera trap confirmations, and conflict incidents in the desert southwest over the past decade constitutes a signal that is consistent enough and directional enough to be treated as a forecast rather than a curiosity. The forecast says that the communities in the path of this expansion are going to encounter bears with increasing frequency. Some of those bears will be passing through. Some of them will be staying. The ones that stay are the ones that will test whether the communities, the wildlife agencies, and the regulatory infrastructure can produce a coexistence outcome rather than a conflict spiral that ends badly for the bears and generates lasting political opposition to their presence. The ranching community in the desert Southwest represents a specific and important stakeholder group in this story, one whose concerns are practical and whose relationship with wildlife management has historically been complicated. Ranchers in southern Arizona and New Mexico operate in a landscape that has always had predator pressure from mountain lions and coyotes and, in some areas, the recovering jaguar population. They have cultural and practical frameworks for managing those pressures. They do not have equivalent frameworks for bears, because bears in the desert lowlands were not part of their operational reality. The introduction of a new large omnivore into the ranching landscape of the desert Southwest is going to create conflicts that the existing predator management frameworks in the region are not fully equipped to handle. Bears and livestock have a complicated history across the American West. Bears take sheep and goats readily. They take young cattle less frequently, but under the right conditions they do. They destroy beehives with an enthusiasm that is almost comic in its single-mindedness, and that beekeepers across the bear range of the American West regard with genuine dread. They get into grain storage. They break down fencing in pursuit of stored food. The conflict between bears and ranching operations is managed in the established bear range through a combination of electric fencing, secure storage, livestock protection measures, and regulated take that gives ranchers a legal mechanism for removing problem animals. In the desert Southwest, where bears are new and where the regulatory and support infrastructure for managing bear livestock conflicts is underdeveloped, the conflicts that arise are more likely to produce unregulated removal of problem animals and more likely to generate lasting community opposition to the expansion. The wildlife management agencies of the desert Southwest are going to have to make choices in the coming years about how proactively they engage with the range expansion that is happening at their borders. The path of least resistance is to continue treating individual incidents as isolated events and to avoid formal acknowledgement of a directional trend until the evidence becomes too abundant to interpret as anomaly. That path preserves institutional calm in the short term and defers the difficult conversations about what the expansion means for existing management frameworks and community expectations. It also allows the conditions that make conflict most likely: community unpreparedness, absence of preventive infrastructure, lack of cultural knowledge, absence of proactive regulatory adaptation, to develop fully before the institutions are ready to address them. The path of more active engagement requires communicating honestly about uncertainty, while still providing the practical guidance that communities need to begin adapting. It requires extending existing bear management infrastructure, food storage regulations, hazing programs, ranger education, into areas where those programs have not been needed before. It requires building the community and political support for bears in new landscapes before conflict erodes it, which means engaging those communities before the first high-profile incident rather than in the aftermath of one. The trajectory of what has happened with black bears at the wildland-urban interface in states like Colorado, California, and New Mexico over the past 2 decades offers instructive precedents for the desert Southwest situation. In Colorado, the black bear population has expanded its range significantly southward and westward over the past 30 years, and the expansion into communities in the southern part of the state generated exactly the conflict pattern described above. Communities encountered bears without preparation. Food conditioning happened before prevention infrastructure was in place. High-profile conflicts generated political opposition, lethal removal of individual animals generated conservation backlash. The cycle of conflict, removal, continued until the Wildlife Agency, under consistent external pressure, expanded its prevention and education programs into the new areas of bear activity, and communities built the cultural knowledge base that allows coexistence to be stable. The process was slow, expensive, and produced worse outcomes for both bears and communities than would have resulted from proactive engagement when the range expansion first became apparent. In New Mexico, the expansion of black bears into the Sandia and Manzano mountain ranges east of Albuquerque, ranges that adjoin the Albuquerque metropolitan area directly and that receive millions of recreation visits annually, created an urban bear interface situation whose management has been ongoing for decades and whose complexity continues to grow as the bear population in those ranges increases and as Albuquerque's eastern urban edge extends further into the mountain foothills. The New Mexico experience is particularly relevant because it involves a bear population at the edge of a desert, because the mountains adjacent to Albuquerque are surrounded on the west by the Rio Grande Valley and on the east by the high desert plains of the Estancia Basin, and because the bears that have come down from those mountains into the city's eastern neighborhoods have done so by crossing a landscape that is, by conventional understanding, not bear habitat. They have done it anyway. The lessons from that situation about what works and what does not in managing bears at the desert community interface are available and documented. Whether the agencies managing the new desert expansion situations in Arizona and Nevada will be able to apply those lessons before the conflicts that make them most necessary arrive is the question that will determine a great deal about what the next chapter of this expansion looks like. The young bear at the Kofa waterhole in 2021 did not know it was in territory that no one had expected it to occupy. It did not know that its presence was anomalous, or that the image from the trail camera would generate conversation among biologists in Tucson and Phoenix. It knew that it was thirsty, and that the water was there, and that no one was at the waterhole threatening it, and so it drank. It carried in its body and its brain all of the flexibility and intelligence and adaptive capacity that has made its species the most widely distributed bear on the continent. It was doing what bears do, which is move through the landscape looking for what it needs and using whatever it finds. The desert, as it turned out, had water. The desert had food, in forms that no textbook had listed as black bear diet, but that a hungry bear will investigate and discover. The desert had, in the immediate sense, no one telling the bear it did not belong there. What the desert did not have, and what the desert communities and the agencies responsible for managing the desert landscape have been slow to develop, is a framework for the situation that the bear's presence represents. The bear does not require a framework. It requires water and food and freedom from lethal threat. The people